In this video, we'll generate the binomial series Pascal triangle coefficients using Taylor-Maclaurin series sum and Linus polynomial regression. Here we have the binomial series of 1 minus x to the power k. Well, the value of k is from 0 to 1, 0 to 8. So we use data validation, list of items, and it's 0 to 8. So these are the values of k, 0 to 8. So we can use our formula. Our formula of the quantity 1 minus x raised to the power k. So at k equals 0, our binomial Pascal coefficient is 1. So y equals 1. At k equals 1, then y equals 1 minus x. Next, we generate the data set of 1 plus x to the power k. So our formula of the quantity 1 plus k plus x, 1 plus x raised to the power k. And the trend line in red is the 1 plus x to the power k. So 1 plus x to the power 1. So 1 plus x, y equals 1 plus x. Next, we generate the Taylor-Maclaurin series sum expansion for both. So which is equal to the summation of a times x to the power n, where a is the combine and n is from 0 to infinity. So starting from 0 to infinity. But 8 is good enough. So we now complete the series sum. So this is our formula, series sum of the x values starting from 0, because this is 0, and incremented by 1. And the coefficient will be this range. Next, we generate the coefficient. So it is equal to, the coefficient a is equal to c to the power n times combine k comma n. But the value of c is c negative 1 or 1. So that's data validation. List of items, negative 1 if it is 1 minus x to the power k, and positive 1 if it is 1 plus x to the power k, and save. So these are the two values. We start with negative 1. So now the value of the coefficient will be r, the formula, c to the power n raised to the power n times combine k comma n, k comma n. So we have an error. 3. This should be 0. So we have to correct this. So this is if error, then 0. Otherwise, calculate. Now it's corrected. So if c is negative 1, then these two are the same. So the Taylor-Maclaurin series sum expansion is equal to 1 minus x to the power k. If c is positive 1, then the red line is on the green. So these two data sets are the same. The Taylor-Maclaurin series sum expansion is equal to 1 plus x to the power k. Next, we calculate the regression coefficients of this trend line equation using Linest. To do that, we have to complete the 1 comma x matrix starting with the power transpose 0 to 8. And we complete the 1 comma x matrix, which is RA formula of the x values raised to the power 0 to 8. Now that we have the 1 comma x matrix, we can use Linest, starting with the 1 minus x to the power k. So Linest data y and data x. And the Taylor-Maclaurin SERIESSUM expansion, which is Linest data y and data x. And the 1 plus x to the power k, again, this is Linest data y and data x. At k equals 3, the red line is on the green. So the red ends are the green. So these two regression coefficients are the same. If c equals 1, positive. If it's negative 1, so the red line is in the blue, then the regression coefficients of the Taylor-Maclaurin SERIESSUM expansion and 1 minus x to the power k are the same. So these two data sets are the same. If c equals positive 1, the red line is on the green dots, and these two regression coefficients are the same. That is the regression coefficients of the Taylor-Maclaurin series of expansion and the 1 plus x to the power k are the same, as well as their datasets are the same. This completes the use of Taylor-Maclaurin series sum Linus polynomial regression to generate the binomial series and Pascal triangle coefficient.